Assalamualaikum, we are from Group 1 and we are excited to share the findings of our project which focuses on analysing traffic load efficiency in Tamban University, Johor. Our study examines the relationship between vehicle volume and delays, providing insight that can help improve traffic management in urban areas. Before we dive into the details, let me introduce the members of our group. My name is Muhammad Yafiz bin Rashdi. Next is Adam Fidas bin Muhammad Nazran, Ahmad Falah Solihin bin Ahmad Afami, Muhammad Azrin bin Rosli, Muhammad Ahmad Faiz bin Muhammad Saidi, and Muhammad Nur Amin bin Muhammad Nur. Traffic congestion is a significant issue affecting urban areas including Taman University. It not only causes delays but also impacts mobility and economic productivity. In this study, we focus on examining the relationship between the number of vehicles and their delays. By using statistical methods such as descriptive analysis and normal distribution modeling and others, we identified patterns and critical thresholds in traffic flow. The findings from this study aim to provide a recommendation for optimizing traffic signals, managing peak hour traffic, and improving urban planning.
Assalamualaikum. My name is Muhammad Azrin bin Rosli. My metric number is CN230380. I want to present about the random variable. First, methodology. Let's talk about the data collection first. We collect two types of data: delay time in minute and vehicle count. Delay time we record in 5 intervals ranging from 0 to 10 minutes. Meanwhile, vehicle count we group in 4 intervals from 50 to 90 vehicles. Next, we move to data analysis. We calculate 3 key statistical measures: the mean, variance, and standard deviation. The mean or expected value help us find the center tendency of the data. The variance show us the spread of data point, and the standard deviation give us an idea of how much the data deviate from the average. We also use the cumulative distribution function or CDF to visualize how probabilities accumulated across different intervals. This help us better understand the distribution of our data. Next, let's move to the result. Starting with the delay data, the mean delay time was 4.3. This showed that most delay were relatively short. The variance was 3.3, indicating a moderate spread around the mean. The standard deviation was 1.8, which means most delay deviate by the 2 minutes from the average. For the vehicle data, the mean number of vehicles observed was 70.6. This tells us that most vehicle count fell in the 60 to 80 range. The variance was 64.0, showing a wider spread in the vehicle number. The standard deviation was 8.0, indicating significant fluctuation in the number of vehicles. Lastly, the discussion. For the delay time, we noticed that most delay cluster around 4 minutes to 6 minutes. The moderate spread suggests that while variation, the delay remain relatively constant. On the other hand, the vehicle can show higher variability. This could be due to various factors such as traffic peak, time of day, and road condition. The higher variance and standard deviation indicate that vehicle count were more unpredictable compared to delay time. Lastly, let's talk about some key insight. The cumulative distribution function or CDF help us visualize how probabilities accumulate around the interval. This gives us a better understanding of the data pattern and variability. This insight can be applied to real-life scenarios such as traffic management and planning. By understanding in delay time and vehicle count, we can design more efficient traffic system and anticipate potential issues. That's all from me.
Okay, my name is Ahmad Falil Salehin. I will tell about normal distribution. The first one, we collect the data on delay times and calculate two key value, the means and standard deviation. We assume that delay times follow a normal distribution, which is a common approach when working with a continuous data that cluster around an average value. Okay, step 2 is to standardize the data. We apply the Z-score formula. This is the Z-score formula. Step 3, we calculate two probabilities. The first one is the probability that delay time exceeds 6 minutes. The second one is the probability that delay time falls between 3 and 5 minutes. Step 4 is the result interpretation. The probability of delay exceeding 6 minutes approximately 19.8%, meaning is relatively rare. And the probability of delay between 3 and 5 minutes is 43%, indicating a moderate likelihood. For discussion, the analysis demonstrate the application of the standard normal distribution to calculate probabilities for specific range. For delay exceeding 6 minutes, the Z-score of 0.87 result in a relatively low probability of 19.8%, indicating that such long delay are less likely. In a contrast, the probability of delay between 3 and 5 minutes is much higher at 42.3%, suggesting that delay times are more concentrated within this range. This information can be useful for decision making, such as setting expectation for typical delays or planning based on the most probable outcome. The calculation also underscore the utility of Z-score cumulative probability in deriving insight from normal distribution. Okay, this graph show a normal distribution curve representing the distribution of delay time in minutes. The curve is a bell shape, indicating that most of the delay times are centered around the mean, with a fewer occurrence at the extreme value. The x-axis represent the delay times in a minutes, ranging from 2 minutes to 12 minutes. The y-axis represent the density which show the relative likelihood of each delay time occurring. The blue curve show the overall delay time distribution with the peak at the mean delay time, which is around 4.5 minutes. Two areas of interest are highlighted. The red shaded represent the probability that delay time exceeds 6 minutes. This area correspond to a lower probability of occurrence as seen from the tail of the curve. The green shaded area represent the probability that delay time falls between 3 and 5 minutes. This area show a moderate likelihood since is it closer to the center of the curve. This graph visually demonstrates that delay time between 3 and 5 minutes are more common, which a delay exceeding 6 minutes are less likely to occur.
Now, sampling distribution for the methodology to analyze traffic flow, we collected data on 30 observations, including vehicle volumes and their corresponding delays. First, we calculated the mean delay and standard deviation using descriptive statistics. Then we fitted a normal distribution curve to visualize how delays are distributed. Probabilities for specific delays were calculated using the Z-score. For visualization, we use frequency and normal distribution graph to highlight the delay trends and variability. All calculations were conducted using standard statistic tools. The results show that the mean delay was 6 minutes, with a standard deviation of 5.31 minutes. Peak delays occur when vehicle volume range between 60 and 80, with most delays falling between 2 and 6 minutes. Additionally, the probability of extreme delays exceeding 8 minutes was calculated to be 6.18%. These findings suggest that traffic delays in Taman University are mostly predictable, with minimal instances of extreme delays. Our analysis reveals that delays are concentrated near the mean, indicating predictable traffic patterns. The low probability of extreme delays suggests that traffic flow is manageable under most conditions. These findings can help optimize traffic management. This graph shows the visualization of the results that we get in sampling distribution.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ramin. I would like to present about estimation for methodology, result, and discussion. For methodology, Firstly, we collected data from a sample of 30 vehicles on traffic delay in Taman University. And then we used the confidence interval formula based on the normal distribution to estimate the population mean delay with a 95% confidence level. And then we compute descriptive statistic including the sample mean and standard deviation. So the result, we found the average traffic delay recorded was 4.56 minutes, and then the 95 confidence interval for the average delay range from 3.9 for 1 minute to 5.179 minutes. For discussion, the average traffic delay of 4.56 minutes indicates a measurable level of congestion in Taman University. And last, the 95% confidence interval provide a reliable estimate of the true average delay, showing a moderate level of variability in the sample data. Okay, this is our graph for estimation. So the graph illustrates the 95% confidence interval for the average traffic delay experienced by vehicle in Taman University. The confidence interval is based on a sample of 30 vehicles with an observed mean delay of 4.56 minutes and a standard deviation of 1.73 minutes. The confidence interval range from 3.941 to 5.179 minutes, indicate that we can be 95% confident that the true average delay lies within this interval. This range reflects the variability in the sample data and provides a measure of uncertainty in estimating the population mean.
Hi, Assalamualaikum. My name is Muhammad Ahmad Faiz bin Muhammad Saidi. My metric number is AN230053. So in this section, I gonna to perform hypothesis testing. So before that, what is hypothesis testing? Hypothesis testing is a statistical method to determine if there is enough evidence to reject a null hypothesis. So the next one is methodology that involve in hypothesis testing. The first step is we need to identify the type of test. We use a Z-test because the population standard deviation is known and the sample size is n is equal to 30. So we need to formulate the hypothesis, null hypothesis, and alternative hypothesis. The second step is determine the significance level. We set a alpha is equal to 0.05, which represent a 5% chances of rejecting the null hypothesis when it's true. And we compare the test statistic with the critical value to accept or reject the null hypothesis. And don't forget to use the Z table to determine the critical value for significant level alpha is equal to 0.05. The next one is a result. For our result, there is insufficient evidence to support the claim that the mean traffic delay is greater than 5.21 minutes and the observed sample mean 4.56 suggests that the delay actually less than the expected value. The next part is discussion. From inside the result, the test result suggests the observed mean delay is lower than expected, and the limitation of the analysis. We assume that the assumption that the population standard deviation is no might not hold in real world scenario. This is a graph of right tail z-test. So the green dashed line represent the updated test statistic, which is z is equal to negative 2.058, and the red shaded area remains the critical region, z greater than 1.645 for the significance level. Alpha equal to 0.05. The red dashed line represents the critical value. Z is equal to 1.645. Before that, how we get the value 1.645? We get by use the Z table and find the value of 0.95 that locate at Z table, and the Z score is approximately 1.645. So since the test statistic Z is equal to negative 2.058 is less than the critical value, we fail to reject the null hypothesis.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Fidos bin Azran, number matrix CN230382. Now, let's dive deeper into the key aspect of this study. By methodology, we begin by carefully collecting data on two crucial factors. We measured the number of vehicles passing through the specific location within Taman University during various time periods. We recorded the amount of times drivers experienced delay at this location. This data collection provided the foundation of our analysis. To understand the relationship between these factors, we employ a range of statistical techniques. These powerful tools help us determine if there was a linear relationship between vehicle volume and delay time, and if so, how strong that relationship was. We also use descriptive statistics to summarize the data, such as calculating average delay times and the variability of both vehicle volume and delay times. Results: our analysis revealed that the average delay experienced by driver in Taman University was moderate. This means that while delays were common, they weren't excessively long in most cases. Surprisingly, we found a weak correlation between vehicle volume and delay time. This suggests that simply increasing the number of cars on the road doesn't necessarily lead to a significant increases in traffic delays. This initial model we used to analyze the data had some limitation. For example, the R-squared value, which measures how well the model fit the data, was unrealistic. This indicates that the model may not accurately reflect the true relationship between vehicle volume and delay time. Discussion: our findings suggest that the factors beyond just the number of vehicles are likely influencing traffic delays in Taman University. These include things like the timing of traffic light, road construction, accident, and even weather conditions. These findings have important implications for traffic management in Taman University. For example, instead of solely focusing on reducing the overall number of vehicles, effort could be directed toward optimizing traffic signal timing to improve traffic flow and minimize delay. To get a more complete understanding of the factors contributing to traffic delays, further research is needed. This could involve collecting more data, incorporating additional variables into the analysis, and using more sophisticated statistical models to refine our understanding of the complex interplay between different factors. Thank you. Conclusion: the analysis revealed that the traffic delays in Taman University exhibit a moderate average with some variability. While the majority of delays fall within a specific range, extreme delays are relatively infrequent. The relationship between vehicle volume and delay time appears weak, suggesting that factors other than vehicle volume may significantly influence traffic flow in the area. This finding can inform traffic management strategies to improve overall traffic flow and reduce congestion in Taman University. Thank you.